Hello everyone. Today we will understand about quantum dots. What are quantum dots? How they are fabricated? What are their potential applications? And what are their properties? This we'll understand today in detail. So quantum dots are basically nanocrystals, or you can say semiconductor particles of very small size. That is in the range of 2 to 10 nanometer. So, hope you remember in the first class of quantum mechanics, we understand whenever we are dealing with the particles at a microscopic level, quantum effects come into play. So, how quantum effects come into play in the quantum dots, we will understand today. So, what are quantum dots? These are basically the tiny particles or the nanocrystals of a semiconductor material having a diameter in the range of 2 to 10 nanometer. They were early discovered in 1980 but came into use later on. So they are basically the artificial nanocrystals that can transport electrons. If we have to understand it, what they are basically, let us suppose this is a semiconductor. So what we will do, we will start reducing the size of this semiconductor. We will come to this stage, then this and this and those, and later on we reach to such a state that further scaling of the dimension is not possible. So because it has electrons inside it, so obviously it has also electrons inside it, and so on and so on. So we reach to a stage where the semiconductor particle is of very small size. This what we understand here, like 2 to 10 nanometer is the approximate size of this quantum dots. So this is a very small size of semiconductor particle is of very small size, having electron inside it. So when because it is a very small size, so obviously quantum effects will come into play. That's why this tiny particles, tiny nanocrystal, is named as quantum dots. So this is so if the semiconductor particles are made small enough, quantum effects come into play. Now when quantum effects come into play, obviously their energy, the quantum effects limits the energy of these particles, whether they are holes or electrons that exist in these particles. So whatever be the behavior, that has to be decided by the energy associated with the particles. So we know that E is equal to h nu, where nu is nothing but c upon lambda. H is Planck's constant, which is very small number. C is velocity of light, and lambda is the wavelength. So we can see here that energy has a relevance with the lambda. So it means whatever be the optical properties, because wavelength came into play, so whatever be the optical properties, that can be decided by the size of the particle. How size of the particle? Because size of the particle is indirectly related to the energy associated with that particle, and energy is further related to the wavelength. So whatever be the wavelength, that has this wavelength means optical properties can straightforward be decided by the size of the particle. So it means optical property of the particle can be finely tuned depending upon its size. So what is overall definition of this quantum dots? Quantum dots are nanoscale man-made crystals that have the ability to convert a spectrum of light into different colors. So it means we are giving them energy, we are giving them light, and they are emitting it into they are converting it into a different colors. Here we can see we are using a particular case of a blue light having wavelength in the range of 450 nanometer, and we are using quantum dots of different size, like 2 nanometer, 2.5 nanometer, 3 nanometer, 5 nanometer, 6 nanometer. And when blue light falls on this quantum dots, as is equal to sc upon lambda, so their wavelength is related to energy, and energy has a relevance with the size. So because of the different size of this quantum dots, we are getting different spectra of light. So this is the emitted light from the quantum dots. Here it is light green, here is a dark green, somewhere it is yellow, orange, and so on. So it's not like only the size of the particle can decide the properties. No doubt the optical properties are straightforward decided by the size of their particles, but apart from that, their size, composition, and structure, these also decide their properties. One more thing, compared to the organic dyes or traditional dyes, they have a lot of advantages. So this we'll understand in the property section. So the properties of the quantum dots are not only determined by the size but also by the shape, composition, and the structure. So they are zero dimensional, reason being we are understanding the particle at a very minute level. So they have a sharper density of states than the higher dimensional structures. So it because they have a very small size, so electrons can travel very fast. So which we can utilize in fabricating the ultra fast electronic devices. They can, because they can emit whole spectrum of light, so they are brighter and have little degradation over time. So this is their benefit over organic dyes. They are more stable as compared to the traditional dyes. So they possess properties of photoluminescence. What are the potential applications? There are composite solar cells, biomedical applications, TVs, display systems, single electron transistors. This is the potential application that we are looking at here, either photon absorption, emission, or tunneling. So by absorption they can be used in detectors, by emission they can be used in lasers, by tunneling they can be used in memories and all. So this is quantum dots can be custom designed for a variety of applications as per the desired requirement. So this is all about quantum dots, which are nothing but semiconductor materials of very small size, which consist of either one or two electrons inside them, that can be utilized for ultra fast applications of electronic devices. Thank you.